हेलो।
यस सर, आवाज आ रही है।
यस सर,
अच्छा
आ रही है आवाज।
अच्छा जी, अच्छा। बिस्मिल्लाहिर्रहमानिर्रहीम। कम दे स्लाइड कम से अच्छा जी। आपको स्लाइड नजर आ रही है?
यस सर।
अच्छा जी। आपके क्लास में कोई फॉरेनर है?
यस
यस
सर।
सर।
अच्छा जी, अच्छा जी, चलें। देन वी विल take lecture in English. If unintentionally I switch to Urdu or Pashto, right, then you inform me. I will start again in English. Yeah, the kasan nakam kaya da where's your यार बल कमरा दे खाली नहीं शकता तो के नहीं साइड के ऊपर शायद तुम टीचर आंदी का ना यो कमरा असल पड़ता है तम के अरसलान दी बिल्कुल नहीं कही नागिन में चाबी बोलूं अब हम इस्तेमाल है अरसलान कमरा की अरसलान कमरा की आगे चाबी पैदा थी अदिल अदिल नशत अच्छा अच्छा. So this is our first lecture. The course name is Foundation and Geotechnical Engineering. It is 2 credit hour course. What I'm going to do in this lecture is to give you an overall picture of what would be in this course, the course contents, and some introduction to foundation, its requirements, and different types of foundation. This is the theme of this lecture number 1. This is how the course would be distributed. Geotechnical design of foundation. That is what we would basically do in this course. Geotechnical design of foundation requires 2 important considerations or criteria to be met. Shear criteria and settlement criteria. What is shear criteria? The soil beneath the foundation should not fail in shear. Your geotechnical design of the foundation should be such that the soil underneath the foundation should not fail in shear. So here you will prevent the shear failure of the soil due to foundation load. And the second important criteria is settlement criteria. It means that the foundation should not settle in excessive amount. The foundation settlement should be within limits. So these 2 criteria are the most important criteria, and we would be discussing in this course these 2 criteria. We would design the foundation keeping in view these 2 criteria. If you have any question, you can ask. देखिए भैया मसाला रहा है ठीक बिल और कच्ची गाड़ी की गाड़ी की shear criteria we would cover in chapter for shallow foundation, shallow and deep foundations. We would cover both shallow foundation and deep foundation. Shallow foundation are those which are built close to the ground surface, and deep foundation go very deep into the ground. Shear criteria for shallow foundation would be discussed in chapter number 2, and for deep foundation it would be discussed in chapter number 4. Settlement criteria for shallow foundation would be discussed in chapter number 3, and settlement of deep foundation we discussed in chapter number 4. So this is the major distribution of the course content, and you can see how important these two criteria are. Settlement criterion, not criteria, and settlement criterion. Shear criterion and settlement criterion. Chapter 1, which is the current chapter, is an introduction to the course and foundation engineering. And one chapter, the last chapter, would be about soil improvement techniques, where the soil is loose, weak, poor, right, for the loads that you are going to apply. So you have different techniques for soil improvement that we would briefly discuss in chapter number 5. Now, in the next slide, I'm going to give you a very brief example how these two criteria are used to design a foundation, geotechnically. If you have any question, you can ask. Before that example, this is the course distribution, week-wise distribution, right? Detailed contents, and these are the books that are recommended. Soil Mechanics by R.F. Craig, Soil Mechanics Foundation by Munibuttu, Foundation and Design by Joseph E. Bowles. These books you can find online. You can find them. Okay. Let's do that example which would clarify to you what is the importance of these two criteria and how it is used to design a foundation geotechnically. This is a frame structure. These are beams and these are columns. You have done structure analysis and you found that the load coming on the center column is equal to 40 tons per tons, right? You have evaluated the strength of the soil and you found that ultimate bearing capacity of the soil is 10 ton per square foot. What does it mean? It means that if the pressure on the soil is 10 ton per square foot, the soil would fail in shear. There would be shear failure in the soil. Text setting the tone of the paste So this is the ultimate bearing capacity of the soil. This is criteria number 1, shear. Ultimate bearing capacity is 10 ton per square foot. That would cause shear failure in the soil. Of course, you are not going to take the stress on the soil up to 10 ton per square foot. You want to keep some factor of safety against shear failure. So if you assume a factor of safety against shear failure equals to 4, the safe bearing capacity would be 2.5 ton per square foot. What does it mean? It means that the pressure on the soil due to structure should be within 2.5 ton per square foot. Right? It should not exceed 2.5 ton per square foot, so that you are much away from 10 by a factor of 4. कोई क्वेश्चन है तो पूछ लें. अच्छा, then we have settlement control criteria. Allowable pressure intensity for 1 inch settlement is 1.8 ton per square foot. This is an assumed value, just for example, right? For this example, it means that if you apply a pressure of 1.8 ton per square foot on the soil, the foundation would settle by 1 inch. Right? So you have to design the foundation such that the factor of safety and shear failure should be 4, should not be less than 4, and the settlement of the foundation should be within 1 inch. I am going to write this sentence. It is important. So we need to design the foundation so that factor of safety against shear failure should be greater than or equal to 4, and foundation settlement should be less than or equal to 1 inch. Okay. So we need to design the foundation so that factor of safety against shear failure should be greater than or equal to 4, and foundation settlement should be less than or equal to 1 inch. So if you assume that there is no foundation, you have directly placed column on the soil, and the column size is 1 foot by 1 foot. So how much is the stress on the soil? Can anybody tell me? Oh, our architect Idris legal. Legally the chair su column place. Sí. Idris number sana kana. Idris number da sara kana. Ya wo sara contact. जी बताएं ना. Tell me how much, if you don't provide any foundation, just place column on the soil, how much stress would be applied by the column?
Sir, 40 square feet.
Yo no do por conmigo, cara. Na verdade. O Rishapana me dio bajavara, ekavara. Yeah, sir, sir. आगे वाने का
हाँ।
खत्म दिखा जैसे नहीं
No. Yo porque a veces va a ده أصل كده
इकला शुरू अब पर अर्थ मत सार रोड अच्छा जी यार one by 1 foot. So, what is the pressure? 40 ton per square foot. Is this so difficult a question that you cannot answer?
सर कमेंट्स में डॉलर कन्वर्ट है
जी क्या बोला?
कमेंट्स में आंसर दी
कमेंट्स तो मुझे नहीं दिखाई दे रही ना दत्तराजी साइड की कमेंट्स नहीं कमेंट्स मुझे आपके नजर नहीं आ रहे अच्छा जी so this 40 ton per square foot is greater than 2.5 ton per square which is allowed for shear it should be less than 2.5 or equal to 2.5 ton per square foot लिखा था ना यार लिखा हुआ सर TSF लिखा हाँ and this 40 ton per square foot is also greater than 1.8 ton per square foot which is allowed for 1-inch settlement. So that's a huge stress. So what you would do, you would increase the base area of the column to reduce the stress. So if you provide a 5 by 5 feet of column, the pressure is now 40 ton divided by 25 ton per square, 25 feet square, 1.6 ton per square foot. So it means 1.6 is less than 2.5. 35 this will become 2.5. Yeah, this is 2.5, right? So shear, there is no shear failure. The shear failure criteria is satisfied, and 1.6 is less than 1.8. It means the settlement would be less than 1 inch. If you have any question, you can ask.
Clear है सर
जी
Some their questions
चलता
students
चला
the classes structure के वो programming के
इधर खाना किस तरह का काम बता ही नहीं
सर
जो कार्य हम स्टेप बाय स्टेप जी आपको समझ आ गई है
यस सर
Yes, sir.
Acha, if you understand it, then tell me, if you provide a 25 feet square foundation, how much would be the factor of safety against shear failure? Can you calculate it? G, what would be the factor of safety against shear failure? When the stress is 2.5 ton per square foot, the factor of safety is 4. When the stress is 1.6, the factor of safety would definitely be more because you applied less stress.
6.25.
6.2.
6.25.
बिल्कुल बिल्कुल ठीक है हाजी नहीं है चोरी factor of safety against shear failure is ultimate bearing capacity divided by applied pressure. Ultimate bearing capacity 10 ton per square foot, applied pressure is 1.6. So the factor of safety is 6.2 against shear failure. तो मत नहीं शिरात ले यार
फायदा हुआ ये चैप्टर मेंशन
अच्छा जी now in this example we assume that we know ultimate bearing capacity of the soil which is 10 ton per square foot. You see خير लेवल बजा कूदिया बाबू Ultimate bearing capacity is 10 ton per square foot. We have assumed this value for this example, but we would find this in chapter number 2 for shallow foundation and chapter number 4 for pile foundation. And we assumed this value of 1.8 ton per square for 1 inch settlement. But how we know this value? This is the theme of chapter number 3 for shallow foundation and chapter number 4 for deep foundation. So this small example covers the whole course, right? That gives you a direction. This simple example gives you direction for the whole course and the importance. See, if you don't have these values, you cannot design a foundation. Remember this, that this is a very simplified example. It has been simplified for you. There are many others, there are complications, right, and details which I have omitted, right? And I gave you a simple example to make you understand. There are details in it. You see, for ultimate bearing capacity equal to 10 ton per square foot for this example, that would be covered in chapter number 2, which would take about 4 classes. And this 1.1 inch settlement for 1.8 ton per square foot, this would also require 4 classes. You can see how much detail and complexities would be there. But this is an oversimplified example to make you understand how this whole course would go. So what is a foundation? You say, the superstructure, and this is soil, and the interface between soil and superstructure and soil is this element is called foundation. The purpose of the foundation is to take the load from superstructure and spread it safely to the soil, right, without violating the shear criteria and the settlement criteria. Who a foundation engineer is? The foundation engineer must have studied courses in geotechnical engineering like soil mechanics, geology, and foundation engineering. But he must also have studied courses in structural engineering to design the foundation structurally. He should have done structure analysis course, design of concrete structures, design of steel structures, right? And in addition to this, he should continue his self-study, do the short courses, attending the conferences, right? After all this, he would be entitled to be called as a foundation engineer. Types of foundation. Types of foundation. You have studied types of foundation in, I think, in building constructions. Here I give you an overview and some more detail which you have not studied. Broadly, we define foundation as shallow foundation and deep foundations. Shallow foundation and deep foundations, right? Shallow foundation have types like single, isolated, and spread footing. And we have strip and wall footing, We have combined footing. Combined footing. It has further types like rectangular footing, trapezoidal footing, strap footing. Map footing, combined footing. And mat foundation. The foundation are another type which we will study in detail in chapter number 4, right? Its types according to material, according to the mechanics, but here we would discuss only the shallow foundation. So the first is the single, isolated or spread footing. Single footing or isolated footing or column footing is provided under a column. This is column, right? This is a steel W section, but it could be concrete. And you have provided a pad beneath the column to transfer the load to the soil. Like in the example, you have increased the area at the base of the column so that the stresses becomes within the limit. That's why it's called spread footing, because it spreads the load in the soil using a greater concrete area. This could be in form of steps like this, you see, because the load under the stresses in the foundation under the column are very huge. So you have provided 3 layers of these concrete, 3 steps. But as you go away from the column, the stresses in the concrete are reduced. So progressively you are decreasing the thickness of the footing. This could be provided in form of steps, in form of slope. As you come closer to the column, the thickness of the foundation increases. Another type of foundation is okay. This is reinforcement detail. You can see this is how the reinforcement is provided under the under the spread footing, because you know that if concrete is weak in tension and strong in compression, and when the load comes, the lower part of the foundation is under tension, right? So that's why you have provided bars in the lower part of the foundation to increase this tension resistance, tensile resistance. And this is a practical picture. Strip or wall footing. Just give me 1 or 2 minutes break, and you take 1 or 2 minutes break, and I will continue.
Yes, sir.
Change foods to go.
speaking certificate from
अच्छा UN के जहाँ अच्छा strip or wall footing, as you know that the spread footing, the column footing is provided below a column, and spread footing is provided, the strip footing is provided under a wall. So this is a load bearing wall, and below this, all along the length, a concrete pad is provided. The purpose of this is also to spread the load of the wall over a greater area on the soil. This is the reinforcement detail. The bending of this would be in the plane of the screen. Bending would be in this direction. So that will subject the lower part of the concrete to tension, so that you have provided steel bars below the pad. Actual diagram here you see wall wala cut ka. You see, this is the steel reinforcement. This blue is the steel reinforcement. These bars are the main bars. These are the main bars. Main bars. Main reinforcement. These bars, there will be no bending along the wall, but still you have provided some steel. These are pressure steel, because concrete would shrink along the length, and that would produce cracks. Therefore you have provided steel reinforcement along the wall. If you have any question, you can ask. Delta nicht? Kalo to. Ahora corpo de processos. Now we have combined footing. इरशाद तब्बल जी तरह से 12:30 बजे कैश क्या तक combined footing. What is combined footing? That is the animation. You have comfort is the one where you combine the foundation of 2 or more than 3 footing. This is called combined footing. It has 3 types. Rectangular combined footing, 2 or 3 columns. You see here, 1, 2 columns are combined. Here 1, 2, 3 and 4 columns are combined. Here 1, 2 are combined. The foundation of these 2 columns is a single unit. The foundation of these 3 columns is a single unit. Now combined footing can be rectangular combined footing like this. This is a plan view. This column number 1, this column number 2, both are combined with a single foundation. It could be a trapezoidal footing, column 1, column 2 in form of trapezoid, or it could be a strap foundation like this. This is one column, this is another column, this is foundation under this column, foundation under this column, and both are combined with a rigid beam. If you have any question, you can ask. Why do we provide a combined footing? Let me explain you the mechanics. This is a column, and this is the property line. There is a top view. This is a property line. So what happens? You cannot extend the foundation into another property. You have to limit your foundation up to this. But the column load is high and it requires a bigger area. So definitely you have to come to the other side. Extend the foundation into your own property. It will be like this. So can anybody tell me, if I provide such kind of foundation, what problem could be there? How it makes the problem? आलमगीर चाहे उसका कहना बोली कोरोना नहीं आ रही है जो 5 मिनट रखा उस मुजाहिद अवसर में खबर हो कि ब्रेक में वापस वो सीला रहा ना क्या ना लो 5 मिनट ना करना बस 5-10 मिनट के ना करना उस कार देखा कर दे सेटिंग क्लास क्लास की चेक Nobody told me what could be the problem if I provide such kind of foundation.
Non-uniform soil pressure.
Non-uniform soil pressure, yes. And I'm going to explain to you why it would be. You see, this is the sectional view. This is load, and this is the centroid of this bed is here. This is the centroidal axis of the footing. On this centroid, this is an eccentricity. Look, this load is eccentric. This is eccentricity. So that system would be equal to like this, a load and a moment. So this is on the soil. Anyway, so this is A combined stress diagram should be drawn. One for axial load, the other is for moment. This is for axial load, P1 by A. They are compressive forces on the soil. You see this blue, these are compressive stresses on the soil. And due to moment, there will be flexural stresses. Here, it would be compressive plus delta plus, watch your sign, delta plus, delta negative. These are, and this is tensile negative, this is plus compressive. So if you combine these two stresses, it would be like this. Here on this side, the stresses will be huge because these two are add up, and here the stresses would be less because they cancel. Here the stress would be equal to P1 by A plus M over S. This is P1 over A minus M over S. So you can see in this eccentric footing, the stress on the soil is unequal distributed. On one side, the soil is subject to huge stresses. Did you understand? You think on this slide for a couple of minutes. If you have any question, would ask.
Okay, sir.
Any question on this slide? Yay. Any question on this slide?
सर ये मूवमेंट वाला जरा एक्सप्लेन करें ए क्यू एम इज इक्वल टू एम बाई
M by अच्छा ये क्या ये that is flexural moment. This is S is the section modulus. अपने बीम में फ्लेक्सर सेक्शन नहीं बट एम वाई ओवर आई या एम सी ओवर आई और आई ओवर सी जो है ना वो एस के बराबर होता है. दिस इज सेक्शनल मॉडुलस ऑफ द फाउंडेशन.
टेंसाइल स्ट्रेसेस हो ऊपर टेंसाइल स्ट्रेसेस हो गया कंप्रेसिव
ये दिस इज डेफिनेट टेंसाइल एंड दिस इज कंप्रेसिव. These stresses want to, yes, and this is compressive. The watch yaar ka la compressive will cover sir, compressive tensile CT. Acha ji, so we want to avoid such situation using direct look, this is rectangular. We have one column P1 which is external column. It is close to the property line, and we have P2 which is internal column. So here if we provide an isolated footing, it has the problem of unequal stresses, right? So what we do, we combine the foundation like this. That is rectangular footing. This is the plan view of that rectangular footing. What we do, first we find the resultant of P1 and P2. This is resultant R. Since P1 is less than P2, this resultant will be close to P2. It will be away from P1 and here. This is the line of action of R. What we do, we provide a rectangular footing such that the centroid of the rectangular footing is in line with the resultant. So in this case, there will be no moment generated. There's no moment because line of action of the resultant pass through the centroid of the footing. Okay, and it would have a uniform pressure distribution. Uniform pressure distribution below the footing. So if you have any question, you can ask. If you have any question, you can ask.
सर क्वेश्चन नहीं है, समझ आ रही है सर.
No, sir.
It's clear, sir.
Acha, now you give me the answer. If P1 is greater than P2, what could happen?
Sir, then movement will produce.
Sir, movement produce होगा, settlement आ जाएगी.
अनइक्वल
क्यों?
डिस्ट्रीब्यूशन होगा लोड का.
Why? When P1 is greater than
जो
P2.
force है
जी.
सर इक्विलिब्रियम नहीं होगा,
P1 के
एक
लिए
साइड पे मूवमेंट ज्यादा होगा.
जी
सर रिजल्टेंट सेंट्रॉइड से शिफ्ट हो जाएगा.
रिजल्टेंट जो है ना वो कहाँ चला जाएगा? वो P1 के
Towards
करीब आ
that,
जाएगा. P1 के करीब आ जाएगा. लेकिन इस तरह क्या करता है यार? P1 would come close, resultant would come close to P1, right? That is the line of action of the force of the resultant. When you make it pass through the centroid of the rectangular footing, you see that would be rectangular footing. What is the problem in this rectangular footing?
सर ये कॉलम बाहर रह गया
बाहर रह गया है, ठीक है ना। और अगर आप इफ यू वांट टू एक्सटेंड दिस टू दिस कॉलम, देन व्हाट वुड हैपन?
सर फिर डिस्ट्रीब्यूशन अनइक्वल हो जाएगी।
Then the centroid of the footing would shift here and resultant would be here. There will be eccentricity, there will be moment, and there will be unequal stress distribution. Why can't we provide rectangular footing when question was? So in this case, we provide a trapezoidal footing because you see that the resultant is close to P1, and in the trapezoidal footing, the centroid is adjusted that it comes under the R. Because in trapezoidal footing, the centroid is close to P1, you see, to the exterior column. That's why we use a trapezoidal footing when P1 is greater than P2. You see, if the distance between the two columns is very large, more than 10 meter, for example, it is 15 meter or 20 meter, if you put a rectangular footing or a trapezoidal footing, your footing would be very long and would become uneconomical. So in that case, we provide a strap footing. In strap footing, what we do, this is one column, this is another column. We provide a pad, we design a pad below this column, design a pad below this column, and connect them with via beam like this. It's called strap beam. So the moments are taken up by this beam, and these two pads are subject to uniform stresses. This we provide when the distance between column 1 and column 2 is very large. So for the economy purposes, we use this beam. So this is called strap footing. Remember that this beam is above the ground. Look, there is above, so that they do not transfer the stresses to the soil. Rather, they only take the bending moments from eccentric loading. Now, last type of shallow foundation is the mat foundation or rock footing. You see, where do we provide a mat or rock foundation, and what is a rock foundation? Now I'm going to explain this to you. You see, these blocks, these are columns. This is a column plan, top view of the column plan. Assume that the soil, you provide isolated foundation below every column, a column footing below every column, you see. And if the soil is weak, the bearing capacity would be low. What would happen? The areas of these isolated footing would be large. The areas would be large, and they would come very close to one another. So practically, it would be good to provide a single footing below all the columns, a single large pad. So what we do, we provide a single foundation below all the columns, like this. So this is called mat or raft footing. If you have any question, you can ask.
सर इस सिंगल फुटिंग की थिकनेस क्या होगी?
वो तो डिजाइन पे डिपेंड करता है ना. That depends on the design, on the loads, on the soil. Right? That depends on the design. When you do calculation, you would know how much thickness is required. That you would do in your RCC design. The thickness of the footing is a subject of reinforced concrete subject. You have any question, you can ask. Acha ji. Another advantage of providing a raft foundation is this. If you provide isolated footing like this, and if it happens that below this column the soil is weak, but below this column the soil is not weak, right? So what would happen? This column would settle more compared to this column. There will be differential settlement, right? And there would be crack in the building. But if you provide a single mat foundation below all columns, so if it happens that there are some weak zones in the soil, they would be bridged over. The raft foundation has the capability, it is rigid, so it takes up the differential settlement. Okay? It can tolerate that differential settlement through its own beam action. Different types of mat foundation. This is one type of mat foundation.
सर जी फिर ये
The simpler one that I explained. जी 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 अच्छा जी. This is the simplest type of
ये
mat.
रेफ्ट सर जी मेट फाउंडेशन फिर अनइकोनॉमिकल नहीं बनता है?
नहीं, this is requirement. When the barrack capacity is low, right? If you provide isolated footing, that would automatically merge with another footing, providing you a single big mat. और जहाँ पे barrack capacity आए हो, then you can go या loads कम हो, right? 2 or 3 story building and soil is good, you can provide isolated footing below the column. But if it is a huge structure like 8, 10, 12, 20 story building, even if the soil is heavy, and if you provide isolated foundation, the stresses would be still high, so you have to provide a mat foundation. Acha ji. So you see, this is a 2-story frame, and below this a huge mat is provided, you see. But sometimes what happens, the column loads are very high. The column loads are very high. So what you do, you provide pedestal below every column. You see, you have thickened the raft below every column. This is thickened raft because you require huge thickness, greater thickness below the column, right? So you have only thickened the raft below the column. The rest of the thickness of the mat is same. So this is for economical purposes, economy. Otherwise, you can provide a very thick raft, but that would be uneconomical. It is better to provide a thickened raft just below the column where the stresses are high. Another option with you is to provide beams below the columns. These are column line. You have provide this beam, you have provide this beam, this beam, this beam, this beam, right? The thickness of the mat here is small, right? But because you required greater thickness below the column, so you have provided beams. If you take a section, you see this is one beam, this is another beam, going all along the column line. Now, this is kind of baffle slab, like you have baffle slabs. You see, the same concept is here. Another type is the same like this, but here you have provided the beams on top surface of the mat. You see, here it was below the mat, here it is above the mat. Oh, pedestals, yeah. These are pedestals. Sorry, these are pedestrians. You see, below every column, you have provided a pedestal on the upside.
सारी पेडेस्ट्रल क्या होते हैं सर?
ये भी कॉलम, जिस तरह यहाँ पे आपने कॉलम के नीचे राफ्ट को टिक किया है, मगर डाउन साइड पे टिक किया है, यहाँ पे आपने अप साइड पे टिक किया है. इस कॉलम
मत स्टेप दिए हुए
जी
सर ये स्ट्रिप नहीं होते हैं, इसका स्ट्रैक्ट होता है.
स्ट्रिप होता है
सर, स्टेप सर, ये जो स्टेप पर सर हम देते हैं सर.
स्टेप फुटिंग जो है ना, उसमें स्टेप फुटिंग.
स्टेप फुटिंग, हाँ, एक किस्म से that is a step. That's a step. You see, this is one step below the column. That is a three picture watch. The last type is this one, where you have a basement. These are concrete basement walls. This is below, and this is slab. All is RCC. The whole system basement is a kind of mat foundation that resists the foundation loads. That is for very high rise building where the soil is weak. You can provide this kind of foundation, which is the most expensive amongst all these types. The basement, the roof, the slab, the RCC was the whole is one single unit of the foundation. Maski open. Hello. Da मतलब दाने चे soil apa ko soil apa ko na weight the types of shallow foundation is now finished. If you have any question, you can ask. Otherwise, we would move on to next article. G. The foundation that we would study in detail in chapter number 4. These are the foundation just for your interest. Actually, शुरू की से तरह मैं खत्म Requirements of foundation system. Safety requirements. Can anybody tell me what are the safety requirements of a foundation system? जी कोई बता सकता है?
जो सेटलमेंट हो उससे स्ट्रक्चर को कोई डैमेज वगैरह ना हो।
और दूसरा?
शेयर फेलियर फैक्टर ऑफ सेफ्टी उसके लिए।
बिल्कुल ठीक है। These two are geotechnical requirements. Factor of safety against shear failure of the soil should be adequate. ठीक है ना? Like the one in the example I explained, settlement, which is total or differential, should be within the limits. You have to design the foundation such that the settlement caused by the loads are within the limits of the superstructure. ठीक है ना? कि उसमें कोई क्रैकिंग ना आए या एस्थेटिकली उसमें कुछ मसला ना आए, ठीक है ना, डोर्स जैम ना हो। These two are the geotechnical requirements. Structure requirement of the safety is there should not be any structural failure in the foundation. There should not be some flexural cracks in the foundation itself, because foundation takes the load from the superstructure and give it to the soil. The above 2 points were related to the soil. The third point related to the foundation material itself. Concrete should be strong enough to be not cracked due to flexural stresses or shear stresses. So this third part you would cover up in the geotechnical, in the RCC course, but the first 2 points would be covered in this course. The second requirement is the depth requirement. What is the depth? What should be the depth of the foundation? What is depth? Is this. This is column, this is foundation, this is ground line, this is depth. How much depth you should provide? So the first is because the topsoil, if there is a freezing temperature in areas where there is freezing temperature, what happens? The moisture in the soil become freezed and there will be volume changes. As the moisture in the soil gets freezed, the volume increases, and when the temperature outside shoots up, it thaws. When it thaws, it melts. What happens? It shrinks. So the top surface of the soil is subject to both these volume changes. So if you put a foundation on that zone near to the surface, the foundation would move along with the soil movement. So you should give enough depth that if any changes occur, that is above the foundation and not below the foundation. This is a map of United States where different contours are drawn. These are the minimum depth requirements, depends upon the frost depth. Further to the north, there is a freezing temperature, so the depth requirement is very high. This is the least. This is the least one. समझ आ गई है?
Yes, sir.
कोई क्वेश्चन?
कोई क्वेश्चन है?
No, sir.
No questions, sir.
अच्छा, अच्छा ठीक है, फिर कोई क्वेश्चन हो तो चेंजेस लेते हैं।
कल तुम्हारा 10 नंबर 10 पे और कंपेयर करें।
अच्छा, क्लास लीव करें सब, अटेंडेंस हो गई है, ठीक है।
हाँ लगा सीधा सी सब जगह करें सबाश वो किया।
Thank you, sir.
फरीदुल्लाह खान, निजाम अहमद क्लास लीव करें।